Modeling a service process in SimPy nearly always follows the same pattern. So in this video, I'm going to show you how to add call triage into our urgent care call center. I'm going to show you how we implement a queue in SimPy where calls are waiting for a call operator. We'll combine that with a delay for call triage. Once we've done that, I'll show you how we link the service process to the arrivals generator. And also using this library, I'll show you a cool tip on how we can improve the arrivals generator function. To correctly model the triage process within our urgent care center, we need to include a pool of call operator resources. In SimPy, we can do that using the resource class. And here we can see that I've created an instance of that resource class called operators by passing in an instance of the SimPy environment and an integer representing the capacity or the number of call operators that are on duty. When we want to request a resource in our service process, we make use of a with statement in Python. So we can see that the operators object has a method called request, and we've used that in conjunction with a with statement in Python. And the return from that value is called req for request. And we then yield that request. Now, what happens within the model is if an call operator is available, that instantly returns that call operator to the calling process. If, however, all call operators are busy, the process will pause at that point and will resume when a call operator becomes available. Now, because we've used the with statement, we have an automatic teardown of this request once we exit that with block or when the indentation ends. At that point, what happens is SimPy will release the resource and it will go back into the pool to be available for other calls that are incoming. So now that we know that, we've got everything we need to write our service function. So it's going to follow these three steps. We're going to request and wait for a call operator resource, wait if necessary. We're going to then undergo phone triage, which we're going to model as a simple delay from a triangular distribution. And then we will exit the system. For the time being, we will ignore the other steps within the model. So I've set up a skeleton of a function here we're going to use called service. That takes 4 parameters. Identifier, which is just an integer value that represents the patient number within the system. It's a unique identifier for that patient. Operators, which is our pool of call center operators. Now we're passing that as a parameter to this function. That's important. We don't want to recreate those operators each time we run a service process. The SimPy environment and a random number generator for the service process. This is going to be used to sample from the triangular distribution. The first thing I'll do is record the time at which this process started by assigning the simulation time to a local variable called startWait. We'll use this variable later on in the function to calculate how long the process has waited for a call operator resource. Next, we'll request the resource. At this point, if there are no call operators available, SimPy will pause the process and wait until one is released. When the process resumes, simulation time will have moved on. So to calculate the waiting time for this resource, we need to subtract the start time of the process from the current simulation time. We'll also print out some debug information so we know that the call has been answered. Next, we need to sample the duration of the triage from the triangular distribution. Finally, we'll print out some debug information letting us know that the call has ended and how long did the process wait for the call operator? And that's our full function for the service process. One thing to note is that all of this simulation logic is indented within this with block. You need to do that, otherwise the resource will be released and your model will have a logical bug. Now you may have noticed that there is a third import to this notebook, itertools. And we're going to use a small slice of itertool functionality to modify our arrival generator function. So our arrivals generator does require a bit of modification in order to link it up to the service process. And while I'm doing this modification, I want you to remember that there is only one arrivals generator within our model, but there are going to be many service processes that the arrival generator initiates. So it's a one-to-many relationship. So the first change that I'm going to make is I'm going to add a parameter to the arrivals generator function called operators, and that's going to be the operator's resource, and that's going to be created externally by our run script and passed to the arrivals generator. So there's only ever one instance of that variable. The second thing I'm going to do is create a second random number generator for our service process, and we'll call that service RNG. And again, there's only going to be one instance of that service random number generator in our model. Then I'm going to modify our infinite loop to use itertools instead of a while loop. We're going to use for call account in itertools dot count, and we're going to start from 1. That's a neat shortcut for creating a unique identifier for each service process that we're going to initiate. So call account increments by 1 each time this for loop is complete, and this loop will continue infinitely thanks to some itertools magic. So the actual sampling of arrival times remains the same. We sample from the exponential distribution, we yield that timeout, and we're going to print out what time that call arrives. I think what I'll also do is just add a limit to 2 decimal places there to neaten things up. And then we're going to add in an additional line of code that creates an instance of a service generator function and passes that to the SimPy environment process method. Service, and the service generator required the following parameters: the call account, so that's the unique identifier, the operator resources, an instance of a SimPy environment, and the service random number generator. So what's happening is each time we go through this loop, the service random number generator is being passed to that new service object. The same for the call operators. Finally, let's take a look at the script to run our model. There's only 3 changes here from our original script. The first is we've now got a variable that represents the number of call operators we'd like to include in the simulation. We create an instance of the resource class that we then pass to the arrivals generator, as it is now one of the mandatory parameters. So let's run this script and see what results we have. So what we'll see is that the first 13 calls to the system will have their call answered at the same time as they arrive. That's because the system starts up empty. Now, as we scroll down the output, we'll see that waiting times start to creep in, and those become a lot more common the further we go into the model, and that's because the model is warming up. So we've got our basic simulation of triage implemented. What would be useful now is to start thinking about how do we collect results, for example, around mean waiting time or operator utilization from what we've already created. And that'll be the subject of the next video.